Today we talk about space and time. Space can be said to be where we move around. We move independently in 6 directions: up, down, left, right, forward, backwards. By independently I mean that neither of these independent directions can be made using other independent directions combined, and all other possible directions can be made using these set of independent directions. These together form the 3 dimensions using which we can locate the position of any event in space. But when that event occurs is also as important, which means we need 4 parameters to completely define an event in space. These parameters are called dimensions. Thus, we come to the conclusion that we need 4 dimensions to completely define our world. So, how to imagine a 4-dimensional world? Well, imagining a 4-dimensional world might be hard, but we can make a mathematical model with the information at hand. We start with the most obvious question: what to do with this when part so that it is usable in calculations with other length dimensions. For that, we need to convert time to a length dimension, and we replace 1 second with 1 light second, which is defined as the distance traveled by light in 1 second. Doing this, we must not forget that length and time are fundamentally different. Well, what we also need now is an axis for time. We choose an axis perpendicular to all other length axes, which means in the 4th dimension. Now on to some interesting stuff. This is a graph representing space and time. We use distance instead of all the other length dimensions separately to make analysis easy for us. This dot here represents any instantaneous event in space after some time and at some distance away from the initial point of observation. If we start moving with some velocity towards the point of occurrence of event, then as time passes, the distance between us and the event occurring would decrease. This would essentially mean that the time axis is tilted for us, because the separation between the time axis and this line was defined to be the distance when we were stationary. But now the separation has decreased to this because we are moving. But what we also know is that time and distance are fundamentally different, which means they have to remain perpendicular. So, we rotate the distance axis also. Now, looking at another simple situation, we have 2 events which occur simultaneously when observed initially. But we also know that these axes will tilt if we start moving. Boom! What just happened? Events which appear to happen together initially now do not appear to happen simultaneously. Well, my friends, this is also a way to look at length contraction and time dilation.